I hope you have this down. And what I didn't do, or I meant to do, is write down what does this mean in plain English. The null hypothesis means there's no difference between summer and winter. And the alternative means that the scores are higher in the summer. Higher in the summer. So let me just reinforce something I said earlier. I'm being a little redundant, but you know, if we just were comparing these two classes, obviously summer did better than winter, obviously. The purpose of the hypothesis test is to make a projection upon all summer and winter courses. And so if it's possible to let these two classes represent all summer and winter classes respectively, then we're going to determine whether summer does better than winter, or if there's not enough evidence to conclude that. So that's the idea there. I'm going to erase the hypothesis test so I can get my next calculation on the board. So now we're going to calculate the t-score, and I like to use t star as my symbol. The book does something a little strange here. Now I know I use t star and they don't. They've got y bar 1 minus y bar 2. Well, that would be x bar 1 minus x bar 2. Okay. I don't know why suddenly he switched to y, this author, but the denominator will be the s times the square root of 1 over the first sample size plus 1 over the second sample size. So there's our formula. I've changed it slightly from the textbook. And let's plug numbers in. Does it matter which one is x1 or x2? No, it doesn't matter. Now what's important is to, in all your calculations, you keep these together and you keep those together. So you can't mix those numbers up. You can't, for example, let x bar 1 be this number and s2 be that number. This would be x bar 1 and s1. So don't mix those up. But does it matter which one I subtract? Not really. If I subtract this number minus this number, I'll get a negative t-score. If I subtract the larger number minus the smaller number, I'll get a positive t-score. The chart in the back of the book doesn't matter if it's negative or positive, so we can conveniently ignore that. I'm going to do the positive route, so I'm going to take 81 minus 77.2. So 81.0 minus 77.2 divide by my pooled estimate for S, 13.64, times the square root of 1 over 14 plus 1 over 11. So there's our calculation. And a small challenge on the calculator. I know what I do. I calculate 1/14 plus 1/11 and hit equal. I take the square root. I multiply it by 13.64. I hit equal. And then I take this subtraction in parentheses and divide by the answer. So a lot of calculators have an answer button that pulls up the number you just calculated for reuse. So anyway, see if you can get the numbers I get. Alright, so raised to the 5 times 13.64. My denominator is around 5.4957. On top I've got 81 minus 77.2 divided by the answer, and I get 0.69. So I'm just going to probably double check that number. But T star I got was 0.69, which seems pretty small to me. I'm just going to double check my calculation here just to make sure, so I don't have to go back and re-record the video. 0.69. Well, let's look that up in the chart in the back of the book, page 650, I think. Excuse me. Page 650. And the degrees of freedom were 23. So I'll go down to line 23 in the pink. And going across, I'm looking for 0.69. By a really odd coincidence, and I didn't make these numbers up, by the way, by odd coincidence, your book has 0.69. Normally, you'll find your calculated t-score in this line here. It'll fall between two numbers. It'll be on the far right or the far left, and then you have to figure out what the probability is. But this one is right on. 0.69 is right on a probability of 0.25. So again, I went down to line 23, found 0.69, and went up to 0.25, which is the p-value. So all this gets us to the p-value, 0.25. And what do we do with a p-value of 0.25? It's considerably larger than 0.05, and 0.05, 5% alpha error, is usually the dividing line between whether we reject a null hypothesis or fail to reject. In this case, because it's high, we fail to reject a null hypothesis. So let's write a conclusion for this, and I'm going to erase most of it so I can get the conclusion in here. Here's my conclusion. We failed to reject the null hypothesis with p-value 0.25. There is not enough evidence to conclude that summer classes score higher than winter classes in Math 160 final exams. And not enough evidence would be only 75% confidence. So I probably should have written that in there. But parenthetically, 75% confidence is, most people in statistics would regard that as way too low to accept an alternative hypothesis and reject the null. So these two samples, not enough. Not enough to tell us that summer classes are better than winter classes. And okay, well, that happens. Now I'm going to erase this and move on to our last example, which is comparing two population percentages.